Look around you. The ground beneath your feet, the sky above your head, the oceans on the horizon. All of them, every single day, are in motion. Most of the time, that motion is gentle. But every so often, the Earth reminds us who is really in charge. In the next few minutes, we're going to walk through every major type of natural disaster. What causes them, how they form, and why they behave the way they do. By the end, you'll understand the science behind the forces that have shaped our planet for billions of years. Let's dive in. Let's start close to home, literally beneath our feet. An earthquake happens when energy stored in the Earth's rocky crust is suddenly released. The crust isn't one solid shell, it's broken into giant puzzle pieces called tectonic plates. And those plates are always slowly grinding past, into, or under each other. Over decades or centuries, stress builds up along the cracks where plates meet, called faults. When that stress finally overcomes the friction holding the rocks together, they snap. That snap sends waves of energy radiating outward through the ground, and that's the shaking we feel. The strength of an earthquake is measured on the moment magnitude scale, where each whole number represents about 30 times more energy released than the one below it. Now let's go deeper, down into the mantle, where rock is so hot it melts into a thick, flowing liquid we call magma. When magma rises toward the surface and breaks through, we call the molten rock above ground lava, and the event a volcanic eruption. Not all eruptions are the same. Some are gentle, with lava oozing out slowly like syrup, building wide, shield-shaped mountains. Others are violent explosions caused by thick, sticky magma trapping gases until the pressure blows the mountain apart. These explosive eruptions can launch ash miles into the sky, fast enough to disrupt air travel and even cool the planet for a year or more. When an earthquake or volcanic eruption happens under the ocean, it can trigger one of the most destructive forces on Earth, a tsunami. Out in deep water, a tsunami is barely noticeable, just a low, fast-moving bump on the surface, traveling at the speed of a jet airliner. But as it approaches shallow coastlines, the seafloor forces that energy upward. The wave slows down, grows taller, and arrives on shore as a towering wall of water that can flood entire cities in minutes. Unlike ordinary waves, a tsunami isn't one crest. It's a series of waves that can keep coming for hours, each one pushing farther inland than the last. Now let's look up at the sky. Over warm tropical oceans, thunderstorms can organize into one of nature's most powerful engines, the tropical cyclone. Warm, moist air rises from the sea surface, spins due to the Earth's rotation, and feeds on the ocean's heat, growing into a swirling system hundreds of miles wide, with a calm eye at its center. We give these storms different names depending on where they form. Hurricanes in the Atlantic, typhoons in the Northwest Pacific, and cyclones elsewhere, but they're the same phenomenon. When they hit land, they bring three deadly weapons: screaming winds, a wall of ocean water pushed ashore called the storm surge, and torrential rain. Tornadoes are smaller, but in some ways more intense. They form most often inside powerful thunderstorms called supercells, where rising warm air and sinking cold air start a slow spin. If that spinning column of air tightens and stretches down to the ground, it becomes a tornado, a funnel of wind that can reach speeds over 200 miles per hour. Tornadoes are measured on the enhanced Fujita scale, from EF0 for light damage to EF5 for total destruction. Most last only minutes and travel a few miles, but the most extreme can stay on the ground for an hour, carving paths dozens of miles long. Water is life, but too much of it in the wrong place is one of the deadliest disasters of all. Floods happen when water overflows onto normally dry land, and they come in several forms. Flash floods strike in minutes when heavy rain overwhelms a small area or a dam fails. River floods build over days as a swollen river spills over its banks. Coastal floods arrive with storms and high tides. What makes floods so dangerous is their reach. They can contaminate drinking water, destroy crops, sweep away buildings, and leave disease behind long after the water recedes. The opposite disaster is a drought, when a region gets far less water than normal for months or years. Droughts creep in slowly, with no dramatic event to mark their start. They begin with a shift in weather patterns that reduces rainfall, and they're made worse by heat, which evaporates the moisture that remains. As reservoirs dry up, crops fail, livestock die, and entire ecosystems can collapse. Droughts are often called the creeping disaster because by the time everyone recognizes one, it has already been happening for a long time. When vegetation dries out, often during a drought, a single spark can unleash a wildfire. Wildfires are fast, hungry, and unpredictable, consuming dry grass, brush, and forest at astonishing speeds. Wind pushes flames across the landscape, while burning embers leap ahead to start new fires miles away. Firefighters describe three things that drive every blaze: fuel, weather, and topography, the fire triangle of terrain. While wildfires are a natural part of many ecosystems and can even help forests regenerate, the worst ones now burn hotter and larger than in the past, fueled by a warmer, drier climate. On steep slopes, gravity is always waiting. When the ground becomes saturated with water from heavy rain or melting snow, the soil or rock can break loose and rush downhill. That's a landslide. Landslides range from small, slow creep to massive, fast-moving debris flows that bury everything in their path. Their snowy cousins are avalanches, which occur on mountains when a weak layer in the snowpack gives way and sends tons of snow racing downhill at highway speeds. Both disasters share a common trigger: added weight and water tipping a slope past its breaking point. Cold brings its own disasters. A blizzard is more than just heavy snow. By definition, it needs strong winds and low visibility lasting for hours, conditions that can freeze exposed skin in minutes and strand travelers. Ice storms coat everything in a layer of glaze that snaps power lines and branches. And in warmer seasons, severe thunderstorms unleash lightning, large hail, and straight-line winds. Lightning, by the way, is the rapid discharge of electricity built up inside storm clouds, hotter than the surface of the sun, striking the ground millions of times every day around the world. So that's the full lineup: earthquakes, volcanoes, tsunamis, cyclones, tornadoes, floods, droughts, wildfires, landslides, avalanches, blizzards, and severe storms. Different forces, different timescales, but the same underlying story: a living, restless planet, constantly moving energy around. We can't stop natural disasters, but understanding how they work helps us predict them, prepare for them, and survive them. If you learned something today, hit subscribe and drop a comment with the disaster you want us to break down next. I'm your Doodle guy. Stay curious,